Good morning friends. In this lecture I am going to discuss standard form 3 students in non-linear partial differential equation of first order. Let us see the concept students. Standard form 3 students. Say here variable separable. Equations of the form f1 of x comma p that is equal to f2 of y comma q. The standard form I discussed in basic concept students, non-linear partial differential equation of first order. You can see there students. What is equation form students? What is equation form? f1 of x comma p that is equal to f2 of y comma q. That means the equation contains the terms students. What are the terms? X, P, Y, Q students. Okay, there are 4 terms students. X, Y, P, Q students. And remember, see here, f1 of xp students. That means xp is one side, f2 of y comma q, and yq are another side students. Okay, please remember the form students. Very important. That is the equations not involving z. Okay students, that this equation not involving z. Okay, there are only 4 terms x, y, p, q. Okay, right. And the terms containing x and p can be separated from those containing y and q. Okay students, x and p is one side and y and q is another side. If you given problem all these mixing, you can write xp is one side and yq is another side students. Right, now I want to find the solution of this equation students, such type of equations. Okay students, I want to find solution of such type of equation. For that, working procedure students here. So it is working rule, working procedure. As a trial solution, assume that each side is equal to constant a. What students? What? No, you make this equal to a, some arbitrary constant students, say a, like this. f1 of x comma p that is equal to a and f2 of y comma q that is equal to a. Now you write p in terms of a and x students. Say he says that solving 1 for p, that means you write p is equal in terms of x and a. So say phi 1 of x comma a, and solving for q, we get q is equal to phi 2 of y comma a, phi 2 of y comma a. Okay students, that means we are finding as usual p and q values, small p and small q values. Okay, now we know that here z is function of x and y. What student? Z is a function of x and y. So z is a function of x and y. Now see students, say dz that is equal to dou z by dou x into dx plus dou z by dou y into dy. Now this is total differential concept students. Total differential. What students? Total differential. Total differential concept in partial differentiation students. So dz can be written as dou z by dou x into dx plus dou z by dou y into dy. Now dou z by dou x means students small p and dou z by dou y means small q. So p dx plus q dy. Okay students, now phi 1 of x comma y. What is p value students here? Phi 1 of x comma a. Now what is q value students? Phi 2 of x comma y comma a. Substitute here. Simply integrate students. Or students, simply integrate, then you get the required solution of given equation or given problem. Once again students, he given what is equation form students. What is equation form? That is important students. f1 of x comma p that is equal to f2 of y comma q. Okay, that means x comma p is one side and y comma q is another side students. Okay, say simply left hand side is x comma p terms and right hand side is y comma q terms, students. Okay, and then to find a solution, we are making that is equal to a, students, that is equal to a. Then we get here f1 of x comma p, that is equal to a, and f2 of y comma q is equal to a here. And then you write p in terms of x and a, students. Similarly q in terms of y and a. Thereby we know z is function of x and y. So dz, students, dz by total differential concept, dou z by dou x into dx plus dou z by dou y into dy. Simply substitute p and q values here, okay, and integrate. Then we get the required complete solution of given problem. Here a and b are arbitrary constants, students. A and b are arbitrary constants. Okay, this is the complete solution, students. Please subscribe this channel, students. Like this video. Share this video, students. Hope you understand. Thank you for watching this video. Jai Hind.